So we've been talking about equilibrium. But what happens if a substance or a reaction is in equilibrium and something changes? So if something changes, that means we put a stress on the reaction. The equilibrium will shift to relieve that stress. So LaChatelier's principle predicts that reactions will that the equilibrium will shift if we put a stress on the system. So let's look at what we would maybe call a stress. So here we've got a reactant and a product, and they're in equilibrium. They've got a reaction going backwards that is the same as the reaction going forwards. So the concentration of the reactants and the products is not changing, and these two rates are the same. What if I dump in a whole bunch of more reactant? Well, that will cause this reaction to go faster. And we say then that the reaction is shifted toward the products. So if I add a reactant, I shift toward the products. So when I add the reactants, I'm no longer at equilibrium and the forward reaction becomes faster. But what if I remove some of my reactant? So there's less reactant present. Well, these start in equilibrium, but if I remove some of the reactant, I'm going to slow the forward process down, and so the reverse process will be faster. And we will shift toward the reactants. So let's see what happens when we mess with the products. Adding more of one reactant will shift the reactant toward the products. And removing it will shift it toward the reactants. So what if we start messing with the products here? What if we add, I'm going to change my color of my pen to a nice blue. So here we go. We're going to add more products. Well, that will increase the rate of this reaction. The backwards reaction is now faster. If we decrease the amount of product, that will increase the forward reaction. So if we add product, we'll shift toward reactants. So this is our summary slide, or our summary table. If we increase the reactant, we'll shift the equilibrium toward products. If we decrease a reactant, the equilibrium is going to shift toward the reactants. So the backward reaction is going more quickly. Forward reaction is increased, backwards reaction is increased. If we increase the product, then we will move toward the reactant. And if we decrease the amount of product, we'll move toward the product. This is how most commercial processes are done. In order to use up all of the reactants, you chemist will remove the product from the solution, often precipitating it, so that by removing the product, you pull the reaction toward the products. So when a substance is added, the system will shift away. Sorry. If a substance is removed, the system will shift toward. You can kind of think of it as if you're removing something, the system wants balance, and it will make more of whatever is being removed. So let's look at the effect of temperature changes. We can think of heat as being a reactant in endothermic reactions and a product in exothermic reactions. And we can use the same rules as we use for concentration. So if we add heat, we will shift back toward the reactants. If we remove heat, we will shift toward the products. Let's look at endothermic reactions. In an endothermic reaction, adding heat to an exothermic reaction will shift toward the products. In an endothermic reaction, heat appears as a reactant. So if we add heat, we'll shift toward the products. If we remove heat, we'll shift toward the reactants. Okay. If we add heat to an endothermic reaction, we expect to shift the reaction toward the products. So this is our summary table. If we add heat to an endothermic reaction, we favor the products. We remove heat, we favor the reactants. Exothermic process, add heat favors the reactants. And removing heat favors products. So we can use the temperature that we run a reaction at to make a reaction more favorable so that it goes to completion. We can also change the volume. So with the volume changes, we need to look at how many moles the reactants have and how many moles the products have. So if we increase the volume, we will move toward the reactants. We'll favor the reactants. If the reactants have more moles. If we increase the volume, but the product has more moles, we'll favor the product. If we decrease the volume and the reactants have more moles, we'll favor the products. And if we decrease the volume and the products have more moles, we'll favor the reactants. So if we increase the volume, the side of the equation with more, it'll favor the side with more molecules. So the more space will favor the side with more molecules. If we decrease the volume, that means we have less space and will favor the side with fewer molecules. Remember, molecules like to have lots of space. One important thing we want to mention here is the catalyst does not change the energy of the reactants or the products. It only changes the path between the two. And so catalyst will not shift equilibrium. It does not affect equilibrium. It speeds up both the forward and reverse reaction the same amount. Was a leftover from something else. Okay, so let's look at some problems. In the lower atmosphere, oxygen is converted to ozone by energy provided by lightning. So we've got 3 O2s plus heat is going to give us 2 O2s. So if I add a reactant, if I add here, we would expect to make more product. If I add my reactant, I would expect to go this way and make more of the reactant. I'll shift toward the reactants. If I increase the temperature, and I'm doing it another color, we're increasing that, we'd expect to go and make more product. If I increase the volume of the container, okay, the way this is written, we've got 3 moles of reactant is going to make 2 moles of product. So if I increase the volume, I'll favor the side with more moles, so I'll favor the reactants. And if I add a catalyst, no change. So let's look at this next one really. Here we've got hydrogen chloride can be made by reacting hydrogen gas and chlorine gas. If we add a reactant, then we can expect to make more product. If we increase the temperature, well, heat here is added just like it's a reactant, so we're going to make more product. If we remove this hydrochloric acid, we can expect to make more of it. We'll shift toward the product. Adding a catalyst, no change. If we remove some of the chlorine gas, then we'll shift the equilibrium back toward the reactant.